Hi, sir.
Hey, Ami, how are you doing?
I'm very good, thank you. How are you?
Very good, very good. So, how's it going at school?
Yeah, all right. Just getting a bit like the workload is getting a bit intense, but yeah, I guess that's how it is when you hit year 12.
That is so
So
true.
yeah.
What do you want to learn today?
hmm well, tomorrow is my two of my maths tests, so I guess the like all those kind of topics put together, which was like quadratic functions and um like so many things put together. So yeah.
Okay. So, we can begin with quadratic functions. I have actually selected some questions for you. So, we'll discuss
Okay.
those questions. I hope that will help. And then later, we can discuss about the other related topics, right? So, I thought this quadratic
Okay.
function is kind of critical for you. All others you have already mastered. So, let me share the screen with you for quadratic functions. There we go. You can see the screen, right?
Yes, now I can.
Perfect. So there are 5 questions on this particular screen. I'd like you to read these questions. And while you read, think about this being your test and also think about the solution. And then we are going to discuss their solution. Okay? Can you please read these
Mhm.
questions?
Yeah, so determine the equation of the parabola passing through the point 2, 5 with real roots at 2 plus root 3 and 2 minus root 3.
Okay. So we are given the conjugate roots, 2 plus minus square root 3, and also a point. And so definitely you can find equation of a parabola. Correct?
Yeah.
Second equation. Second question.
A parabolic arc is 60 meters high and 6 meters wide at a height of 9 meters. A. Model the arc with a quadratic relation.
Mhm.
And B. What is the width of the arc at its base?
Correct. What will be your approach to solve this?
So if I start with a diagram,
Yeah,
um, it's 60 meters high and 6 meters wide. So it would be like an what is it? Upside down. Yeah.
correct.
And then we're saying it's 16 meters high.
So in
So
such
but the
questions,
height is 9.
yeah, so what you will do is you will take the height along the y-axis. So that will make it very simple to solve. You get the idea? And when you say a parabolic arch is 16 meters high, so that is the maximum height, and 6 meter wide at height of 9 meters. So if I take this as my 9 meters as my height, so it is 6 meter wide.
Mm-hmm.
That means from here to here, this total distance is 6 meters. You get the idea? So if I use
Yeah.
reference like this y-axis for the maximum, then I know this particular point here is 3 and the other point is uh, kind of minus 3 on this particular scale. Correct? I mean,
Yeah.
for this point, not that. Um, you get my not this, but
Yeah.
minus 3 and plus 3 for these points at the
Yeah.
height of 6
9.
9 meters. So this point is 9. Do you get? So we already have these points, the maximum point being at 16. Now,
16.
since we know these 2 points, rather we know 3 points, again, we can easily find the equation of the parabola. However, making a reference frame like I've shown here helps you to find quick
Mm-hmm.
solution to such questions. Okay?
All right.
Next
Yeah.
question.
Solve the inequality 6 over x squared minus 5 over x, whole thing greater than or equal to 1.
Yeah. So when you read this question, what
Mhm.
comes to your mind and what is the strategy for you to solve this question?
So I was actually doing a similar one today in my book, and I do remember you saying whenever we deal with these questions, you can't just like you can see both of them could have this common base of x squared
Yes.
as common, but I prefer to do it like individually. So if you multiply the whole bracket by x squared,
Hmm.
then but it has to be x squared. You have to have even powers so that
Yes.
it will always be positive. Whereas if
Yes.
you do like odd powers, it could be both positive or negative.
Yes.
So then you can just use x squared, cancel it out, and then solve the quadratic, make
Yeah.
it greater than or equal to 0.
Correct. So what you're trying to say here is something like this. If I multiply by x squared, I get 6 minus 5x, correct? Greater than
Yeah.
equal to x squared as my
X
equation,
squared.
right? Now,
Hmm.
when you do like this, there is one big problem, and that is while solving, students forget that there is a restriction, and that is x is not equal to 0.
Zero.
So, in your answer,
Uh-huh.
you cannot include 0. So, this strategy is pretty good. However, it has a risk factor. That is, when you get into the zone of solving a question, and you find
Right.
a solution, you actually forget by that time that the question was 5 over x, 6 over x squared. X cannot be 0. You cannot
Hmm.
include 0 in your solution. So that is a key. So when you multiply or do anything with rational expressions, first thing you have to write is the restriction so that you know what is the domain for the solution. Clear?
Yeah. Uh-huh.
Now, can you please read question number 4?
Given that f of x equals x squared minus 4x plus 5, find the area of the quadrilateral VAWB, where V is the vertex,
Mhm.
W is the point on the intersection of the axes, and the x-intercept and the points A and B are 2 units away from the axes of symmetry.
This question is slightly complicated. We'll actually discuss this at length when we come to the solution. However, my idea of putting this question here is to understand that we can actually have a question where axis of symmetry is the major focus. Normally, the vertex is the focus or the intercepts are the focus, right? But this is a
Yeah.
unique question in the sense that we are actually referring everything with respect to the axis of symmetry. That's very important.
Oh, right.
Right. So
Mhm.
now, can you please read question number 5?
Rogers Centre, with capacity of 50,000, is being considered for a music concert. 20,000 seats have been blocked by sponsors. From the past experience, it is known that 10,000 tickets can be sold if each ticket is sold for $30. It is also known that 1,000 more tickets can be sold for each dollar reduction in the ticket price.
Mhm.
A. Find the number of tickets T sold as a function of price P of each ticket.
Mhm.
B. Find the revenue R as a function of P. And C. Find the ticket price to maximize the revenue.
Correct. Now,
Mhm.
this is a real life situation. Our Rogers Center is one of the biggest and attraction of Toronto, right? It's a beautiful building,
Okay.
which yeah, where the whole roof can be retracted. So it's a excellent, it's a
Oh.
marvelous architecture. Yes, it is, and it has a capacity of 50,000. And practically, all these matches which take or concerts, big concerts, it's a venue for those concerts and even some matches, right? Like we have a
Oh, okay.
great teams, right? Now, normally these are all sponsored events, and the best seats are occupied or sponsored. So for the people at large, they have only few seats available, which are right on the periphery, right,
Mhm.
far away, kind of. And these guys
Right.
are ready to sell them at any cost, right? It's
Hmm.
kind of because they've already taken out all the money for the concert or any particular program which is going there.
Right.
So,
Yeah.
key parameter here from the past experience, it is known that 10,000 tickets can be sold if each ticket is sold for $30. It is also known that 1,000 more tickets can be sold for each dollar reduction in the ticket. It makes sense because there are 50,000 seats. Only 20,000 have been paid for in a way. So they need to sell 30,000 seats, correct? And they know that 10,000 can be sold, and they need to have some marketing stunt. And that is where the quadratic equation will play a great role. We'll kind of model and see how to do such
Hmm.
questions. Okay. So let's begin with
Okay.
example number 1. Example number 1 is determine the equation of parabola using passing through the point 2, 5 with real roots at 2 plus 3 and 2 minus 3. So we're given two real roots. As you know, we can write this equation in the factored form. So y equals to a times x minus x1 times x minus x2, where x1 and x2 are the real roots. So in this particular case,
Mhm.
we'll write the function as f of x equals to a times x minus the first factor, x minus the other root, right? and then we need to multiply and simplify. However, you will notice here that I used difference of square to expand it. You remember what is a plus b times a minus b equals to, right? It is a square minus b square. So
B squared. Mhm.
that helps us to simplify the calculations because this calculation is huge otherwise. So you what you notice here is that x minus 2 you could treat as a, right? Kind of one term. And so it becomes x minus 2 plus 3 times x minus 2 plus square root 3 and x minus 2 minus square root 3. So that gives us a square minus b square. And as you know, square root of 3 square is 3, right? And therefore, we have written this.
Right.
So it helps to ease out the calculation, saves a lot of time. So this is a beautiful step which you should look into and understand, right? Then,
Yeah.
of course, we need to find the value of a. We are given a point which is 2 and 5. This point, if you place the x value at 2, the y value as 5, you can find specifically what should be the equation. Otherwise, we get a family of equation with this factored form. So substituting this point and solving, we get the value of a as minus 5 over 3, and therefore that becomes our function. Is that clear to you? So
Yeah.
this question seems to be very simple and straightforward. The very first question here. However, in just expanding this part,
Not
sometimes
really.
it may be
Yeah.
difficult to get the right values. Okay,
Mhm.
let's move on to our example number 2, which is a parabolic arc is 16-meter high and 6-meter wide at the height of 9 meters. So at the height of 9 meters, what I've done here, as you can see, this is the height of 9 meters. I have taken the width as 6 meters. That is to say, from minus 3 to plus 3. You get the idea. So that gives you 6-meter high, 6-meter wide at the height of 9 meters. The other parameter given to
Mhm.
us is 16-meter high. So that becomes the vertex. So in this particular case, when I use y-axis as my axis of symmetry, the question becomes
Mhm.
extremely simple because now I can say that the equation is ax squared plus 16, right? Because the vertex is on the y-axis. So f of x is ax squared plus 16.
Mhm.
To find the value of a, we already know these 2 points. We can use any one of those points. We need to find just one parameter. So I'm just using one point, which is 9 and 3, right? So we know the at x equals to 3, the value is 9. Substituting that, we get the value of a as minus 7 over 9. Substituting minus 7 over 9 in our equation, we get the equation. So that is how you will get part
Oh.
A. You get the idea.
Mhm.
Part A, which
Yeah.
is we model the situation so easily. Do you understand? This sentence with
Yeah.
very few words has a lot of material in it. It is not a simple sentence to even understand. Okay. Now, part B is what is the width of the arc at the base? So we need to find this width, right? This width that we can find as x-intercept. So basically, we are now trying to find the x-intercept. That is, f of x is 0. The y value is 0. Substituting, you can always find, taking 16 on the other side. Whenever you do square root, you have to do plus and minus. And here, definitely, you're looking for two roots. Those are at plus
Mhm.
minus 4.535, multiplying by 2, that is adding them together. One is negative, one is
Yeah.
positive. We get 7.07 meters as the answer for part B. Is that clear to you?
Oh. Yeah. And that's the width of the 16-meter high one.
Yes. So this
Yeah.
is the width at the base, right? So that is how you're going
Mhm.
to do it. So I'll actually
So
upload
what
this
you're
link.
saying here
Yeah,
is the key point is making this whole thing like symmetrical about the y-axis so that you can simply just write ax squared plus 16 because the
that is
vertex would be at 16.
perfect. Perfect. That is the
Right.
it saves a lot of time, right? There could be so many other
Mhm.
ways of doing it, but this is the best way of doing
Yeah, definitely.
it.
Because
Right.
I was gonna be doing like you said, the ax squared plus maybe bx and then
Mhm.
plus 16 like that, and that would have been
Yeah.
so long.
You could do like that because 3 points are given to you, right? We have 3 points, 3 and 9, minus 3 and 9,
It's
and the vertex.
long.
but that'll be too long, correct?
Mm-hmm.
Yes.
Yeah.
Now, let's move on to question number 3, which is inequalities. We need to solve the inequality, which is 6 over x squared minus 5 over x greater than equal to 1. Now, key thing here is to identify the restriction. The restriction is that the denominator cannot be 0, so x is not equal to 0. So make that a point when you get a rational function, okay? So
Okay. Yep.
what I've done is, in a way, I took x squared as common denominator, right? Brought all the terms together, moved this to the left hand side, and then took x squared common denominator. So I'm not canceling it out. I'm
Mm-hmm.
not really multiplying by x squared on both the sides. I'm keeping that x squared there itself so that I can
Mm-hmm.
see that, well, x squared is in denominator and it cannot be equal to 0. You get the idea, right?
Yeah.
So the
Mm-hmm.
numerator definitely is same as what you will get otherwise. But I will prefer to keep x square in the denominator just to give me an idea that x cannot be equal to 0. Now, we get the
Right.
numerator
Okay.
which can be factored very easily. In this case, x plus 6 times x minus 1 divided by x squared, and that has to be less than 0. Now, at this stage, you have many options. One, which I have done here, this is the lengthiest part which you could do. Here we have two zeros and a vertical asymptote at 0. So that divides our plane into these four intervals. I've taken test points of minus 7, minus 1.5, and 2 within the intervals of minus infinity to minus 6. That is this 0. And then from minus 6 to 0, which is in between that. And then from 0 to the next x-intercept 1. And then from 1 to infinity. Well, there are only three factors to test. We just test them out with these test points and then work out which are the values which give us negative answer. Less than 0 means negative, correct? So we get our solution, which is these two different intervals. Don't write them together because in between 0 is not
Mm.
included, correct?
Right. But can
Not,
you not include the minus 6 and the 1?
oh yeah, you're so right. So
Oh,
right. Yes, 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 yes. Yes,
square
yes.
bracket. Yeah. Okay.
Thanks a lot. Thanks a lot.
That's all right.
So
Just checking.
that is perfectly fine. Too much into that. So when you write these points, it's a good idea to write 0 with a filled in dot. So I have filled in circle for 0 and for, I mean, the zeros means the x-intercept. At 0, we have vertical asymptote. I put a hole there. So clearly, that is the solution. Well,
Oh, okay. Yep.
fastest way, and thanks, Amy, for reminding me this, we have to include because it is greater than equal to. Perfect. Now, the fastest way at this stage also is we know x squared is always positive. We know x squared is always greater than equal to 0. So we are only worried about the numerator part, which is the parabola. So what I could do here is that I could actually sketch a parabola at this stage. I have a parabola kind of like this. You get the idea, right? And we are
Mhm.
looking for a portion which is negative, and clearly we get our portion within the interval minus 6 to 1 to get that is our portion, correct? And of course, not forgetting that x is not equal to 0, we could write that the interval is from minus 6 to 1 where x is not equal to 0. We could also write like this. Is that clear to you? Writing
Yep.
separately that x is not equal to 0. However, the best method is to write the answer as we wrote here. Perfect. That is, we have the value where minus 6 and 0, 0 not be included, and union, we have from 0 to 1. 1 is included. Perfect. That becomes the solution as we have shown here. Correct? Is that clear to you?
Yep. Yeah.
Be
It's clear.
absolutely clear because you pointed out the right thing. All right. So, only thing which is very important to understand is that look for the restrictions, do not include them in your answer. Perfect.
Right. Hmm.
Now, let's take example number 4. Can you please read this question?
Given f of x equals x squared minus 4x plus 5, find the area of the quadrilateral VAWB, where V is the vertex, W is the point on the intersection on the axes, and the x-intercept and the points A and B are 2 units away from the axes of symmetry.
Perfect. So now, given function x squared minus 4x plus 5, So basically, it's a
Mhm.
function which will open upward. So we can have a parabola which opens upward. Then find the area of the quadrilateral VAMB, where V is the vertex. So we are given a point which is the vertex right there. V is the
Right.
vertex, and this point is V for you. W is a point on the intersection of the x-axis of the axis and the x-axis. So let us say this is your x-axis and this is the axis of symmetry. Then W is the point which is right there. You understand this statement? W
Right.
is the
Yeah.
point on the intersection of the axis, x-axis that means, and the x. W is the point on the intersection of the axis and the x-intercepts. No, there's a problem. And the x-axis. And the x-axis. Okay, I made an error in typing. Okay. So W is the point on the intersection of the axis, which means the axis of symmetry for parabola, and the x-axis. So that is W, which is on the intersection of x-axis, the horizontal x-axis, right, and the axis of the parabola.
Mhm.
And points A and B are 2 units away from the axis of symmetry. So that distance is will be always equal when we see the axis of symmetry. Now we are saying points A and B are 2 units away from the axis of symmetry. So that means both are 2 units. So this is 2 units away on this side, the other one is 2 units away on the left side. That is what this question is trying to say.
Mhm.
So or it could be more explicitly written as the points A and B are each 2 units away from the axis, correct? To be very clear that each one of them
Mhm.
is 2 units away. So that becomes your question. Now, based on the question, what we've done is sketched a diagram here to understand the solution, right? So this parabola is shown in red. The axis is right there where you have the vertex, right? And so that is the point where the x-axis intersects with the axis of the parabola and the points A and B, which are 2 units away, right? This diagram will actually get after working out most of the things. So let's see how to solve the questions. You'll start from here, correct? You'll make a rough sketch saying a parabola will be something like this. Point V is right there, W is on the other side, and we know A and B. We need to find the area of this quadrilateral, which is this is A and B, correct? So we'll start with this rough sketch to begin with. Okay. So clearly, we have the function which is x squared minus 4x minus 5. And from this function, we can find the axis of symmetry. Can you tell me, how did I write this axis of symmetry from standard form of the equation?
Um, so I remember you teaching whenever you find the axis of symmetry, if you have that standard form, minus b over 2a is the formula to use.
Very good. So y equals to x squared plus bx plus c is the general equation in standard form, where x equals to minus b by 2a is the formula to be used. And many ways you can figure it out because b squared minus 4ac, that square root term should be 0 for one point, correct? Which is the vertex. That also gives you minus b by 2a if you put the other part of the quadratic solution as 0, correct? So yes, minus b by 2a gives us the axis, which
Yeah.
is x equals to 2. So now we got this axis x equals to 2. You can substitute 2 and find the y value, which will give you the vertex. So now we know that the vertex is at 2 minus 9. Correct? When I substitute 2 in my function given to me, I found that f of 2 is minus 9, and therefore the vertex is 2 minus 9. Now, 2 is my x-axis, correct? Definitely, the point where it is going to intersect the x-axis y value will be 0. So the w is 2, 0. Got it? W will
Mhm.
be 2, 0 because the y value has to be 0 on the x-axis.
Yeah.
Perfect. So we get
Right.
these 2 points. Now we'll figure out how do we find A and B. Okay. A and B are 2 units away. I could have actually also found this from step function. You remember 1357 is the step
Mm-hmm.
for a quadratic function, right? So one step will be 1 unit away, right? Two steps, the y value will be 3 times because the coefficient is a, right? 3 units out, 3 units out, correct?
Right.
From step function also, I could have found
Mm-hmm.
that the coordinate of value, which is 2 units away. That means if it is on 2 units to the right, x is being at x equals to 2, 2 plus 2 is 4. So x value is 4, right? And at 4, I have to just add
Right.
uh,
Yeah.
plus 4 to get the value of y, which is minus 5. I could have got from here also. However, it's easy calculation. We know the axis is at 2. So 2 units to the left and 2 units to the right basically means we want to find the y value for f of 0 and f of 4, correct? Because f of 2 is the axis. Clear? So 2 on the left will,
Just quick thing. If you
yeah,
didn't do, sorry, yeah, if you didn't do the step function,
yes.
could you find where A and B is just by finding like, is the A and B line in the middle of 0 and -9?
I'm actually a written solution here. We are not using the step function. We know the axis is at x equals to 2, right? We
Oh.
found x is at x equals to 2. Now, 2 units to the left means x equals to 0, right? 2 units left
Mm-hmm.
of the
All
axis.
right. Yeah.
And 2 units right will be x
Yeah.
equals to 4. So I'm only finding the value for f
4.
of 0 and f of 4 to get my points A and B. You see that?
Oh. Yeah,
Yes,
that's good.
yes, yes,
Oh,
yes.
I like that. That's clear. Yeah.
Yeah. So actually, that is what I followed, and that is the standard way of doing it. But I was just telling you that you could actually,
Mm-hmm.
on a graph paper,
Yeah,
find the
yeah, it's good to know.
point very easily, right? Anyway, so that is
Right.
one
Yeah.
point. And of course, the y values have to be seen because we are checking the values with reference to our axis, correct? Axis of symmetry. That's what it means.
Right.
We have both the points A and B, and now our quadrilateral is defined, correct? Because we know already we found what
Mm-hmm.
points V and W were. Perfect. So
4
basically,
points.
yeah,
Right.
4 points will divide with the center line AB joining them into two triangles. So we have half base into height. Height is very clearly known here because of the y value difference, right? So this is the height, correct? So if my
Right.
this point y-intercept is at -5, that means the height is 5 on this side, and from vertex it is 4, right? The, that triangle, correct? So we have two triangles. We know their height also very easily from the graph itself. Base, both of them, is A to B. And A to B is 2 units, and 2 units means 4 units, correct? We know the length AB is 4 units,
Right.
right? So AB is 4 units. So we can use AB as 4 units, and height of one of the triangles which was on the top as 5, the height of the triangle which is the bottom as 4, and we can calculate this area easily as 18 units square. Does it make sense to you?
Yeah. Yeah. It's
I'd like
clear.
you to go through this example again, understand the concept. This involves
Mhm.
a lot of concepts, but once you understand, it's a very simple question to solve.
Yeah.
Okay,
Yeah.
so let's
I'll
move
try
on
it out after
and get
this.
to the Rogers Center. So Rogers Center with capacity of 50,000 is being considered for a music concert. 20,000 seats have been blocked by sponsors. From the past experience, it is known that 10,000 tickets can be sold if each ticket is sold for $30. It is also known that 1,000 more tickets can be sold for each dollar reduction in the price. So if I make it 29, I can sell 1,000 more, means 11,000 tickets will be sold. If I reduce the price to 28, 12,000 tickets will be sold, correct?
Oh.
That is the
Mm-hmm.
strategy. If T tickets are sold, that means I sold T minus 10,000 extra tickets, correct? I
Right.
sold T
Because
minus
10,000 can be
10,000
sold.
without
Yeah.
any discount. So T minus 10,000. But then for every extra sale, what was the discount? Discount was for every dollar, 1,000 seats. So $1 per 1,000 is the discount on the rate. Therefore, my price has been reduced from 30 to 1 over 1,000 of the extra tickets sold, which is T minus 1,000. You get the idea.
Yeah.
And now I get the price of the ticket
Yeah.
at which the stadium was booked, kind of, right? Do you understand? So
Yeah. All right. Okay.
T is the number of
Then you
tickets
just
sold.
expand.
Perfect. T is the number of tickets sold. Increased tickets sold is T minus 10,000. For this increase, we
Mm.
gave a discount on the price, which was $1 for every thousand. So $1 for every thousand. And that was reflected on the additional tickets. And therefore, the price
Oh.
was not 30 now. Price is less than 30. For every dollar reduced, we got 1,000
Yeah.
extra marketing done here, right? So 1,000, 1 over 1,000 times that. And so we get a price function. Now see what part A is. Part A is find the number of tickets T sold as a function of price. The equation is price as a function of tickets sold. So we'll have to rearrange them to find really what is T
Mhm.
as a function of P. So we just rearrange, giving
Right.
our equation, expand it first, bring all the terms on T to the left side, make it as your main parameter, and then that is the subject, and then you write down the equation and you get your answer that T as a function of P is 40,000 minus 100P. Is that clear to you?
Hmm.
Well,
Yeah, I think with this question, it's more about depicting the paragraph and putting into like a mathematical sentence, you know,
correct,
like you did T minus 10,000. It's about analyzing that, and that bit I do find a little bit tricky because word problems. That's
correct.
why I didn't take English because it's too wordy.
Correct.
Yeah. But
Now,
yeah, this makes sense now. So it's just
correct,
about, like you said, doing it step by step, kind of breaking it up.
correct.
Yeah.
So the next two parts were revenue. So we'll do completing the squares. So next part is find the revenue R as a function of P this time, okay? And then part C is find the ticket price to maximize the revenue. That is completing the squares. So I've just combined both in one short step here. So revenue is both product of number of tickets sold and the number of price of each ticket. So when we multiply the number of
Hmm.
tickets sold by the price, we get a quadratic equation for the revenue, and that is what it is. And that is what you can say is find revenue as a function of P. So this is the first part, which is revenue as a function of P. Is that clear to you? Then I continued with
Yeah.
completing the squares method. So answer B has been done at this stage. And then we continued to find what is the maximum revenue and what is the minimum price, right? So when you complete the square,
Hmm.
take the coefficient of p square common minus 1,000. So we get p square minus 40p. Now, half of 40 is 20. Add and subtract 20 square. Add and subtract 20 square, and you get a first three terms as a perfect square. P minus 20 whole square. 20 square is 400. Open the bracket. Minus 1,000 is being multiplied with both. That gives you the vertex, which is at 20, and the y value being 400,000.
40,000. Oh,
400,000, right? So that is your where
yeah.
clearly the price is what $20 is, and the revenue is 400,000 for you. Is that clear to you?
Yeah.
First,
So when you get it into the completing the square format, you can
yes,
just like take the values out to find like the optimum. Okay.
yes, perfect. So with this, we have solved these five very critical questions based on quadratic relations. Amy, how do you find them? Can you summarize our learnings today?
Yes. So in these five questions, we kind of touched upon all the quadratic relations and definitely like the applications to them. So as we progress through the questions, like the last one, it became more like real life kind of perspective. So in the first like couple, we're just seeing equations and how they're dealt with. But then in question five, like seeing how in real life using different models and how the quadratic formulas and things apply. That was very important. So if I just go through them quickly and just say like what the key points and tips that you can get. So with number one, so yeah, when you see two roots and you know how you usually just write x minus that and then put them in brackets. when you expand that, obviously dealing with surds and things can be a little bit tricky. So like we saw when you put them together, you saw the x minus 2 and how they were common. So you took that out and then squared that. And then with the surds, with root 3 times root 3 is 3. So getting rid of surds and stuff is very important, because then it's easier to deal with. So always simplifying and making it easier for you to solve. Then with 2, what was 2?
That parabola.
This. Yeah, so making the diagram is so handy, and I found the axes and everything with that was so critical, because if you make the axes like I talked about when we did this, if you make the axes which is not at 0, which is the y-axis, and if it's not there, it's not symmetrical, then it's going to be so hard. It's going to be like crazy hard. Here it's so clear that ax squared plus 16, because the plus 16 is what the vertex is. So then you just literally solve from that, and then you've got the points and work like that. Although you can do it the whole standard form, ax squared plus bx and then plus 16 like that, and you've got your 3 points, but that's just too long and you need to find shortcuts and things, so you can use that time elsewhere. Question 3 was
inequality with x squared in the denominator.
So when you see questions like this, finding a common denominator, that's easy to work with. So in x squared in this case, and then after you do so, the main thing you do when it comes to rational functions is always write down the restriction first, because that's so important. Don't start attempting the question like I just did, because when you come to the solution, and let's say one of the solutions was 0 and you put it as included, that's incorrect, because x cannot equal 0. Perfect. So it's very important, because you need to know that. So always write down restrictions. And then
the coordinate
axes of symmetry.
Yes.
So key formula when it comes to the quadratic, the ax squared plus bx plus c, is knowing minus b over 2a is the axes of symmetry. So you can find that with any graph, and then knowing that and making that as your kind of your usual origin when x equals 0 kind of thing. You're using the same rules and everything applies the same. It's just maybe in a different place. So, but it still works the same. So that's important formula to remember. And then with 5, again, this is with the whole real life concept, and about taking parts of the passage and kind of breaking it down into mathematical terms. So I think this is just practice, because you can't just say this is how it is. It's over time, you'll get used to it.
So that was beautifully summarized, and I think many students will benefit from how should we be solving such equations or questions, correct? So with this, we can end our video today. All the best to you, Amy. And do share with me any questions which you come across. Okay? All the best.
Yes, will do, sir. Thank you so much. I really appreciate it. Thank you.
Thank you. Bye.
Bye.